All right, so we're all set. So this talk is partly about APIs and partly about Scala, but I want to know something. Who here is using Scala at work? All right, good show of hands. And who's writing APIs as part of their work? Cool. So who's writing enterprise APIs, APIs meant for internal customers? Awesome. Then this talk should be really well applicable. Because you folks are a great audience for this, I want to talk about kind of a case study of how we were able, our team at Netflix was able to build some enterprise APIs at an astonishing velocity, and some of the best practices for doing so. I think enterprise APIs are great. By this, I mean APIs used by mostly internal folks, maybe for some tools with specific parties, but not really part of your main site. So I think some of this is pretty applicable, and boy, I'm really struggling with that. I shouldn't have had that beer. It's pretty applicable to different kinds of development, but I want to talk about really how you can be really effective at this particular area. So this is another title for the slide. This is how in 5 months, 2 Netflix engineers were able to build 150 well-tested and well-performing APIs with, again, with 5 months and really no downtime. So, hi everyone, I'm Jason Swartz, one of the organizers of this group, and you can find me on all these places. And I want to tell you a bit about what we did with this. So, I work at Netflix, and if you guys have the site and have the service, and I hope you do, you've probably seen the main front page that we have, where we have clients that run on all these different devices and talk to our main APIs, and that's really great. I wish I could talk to that, but I don't actually know how that works. I actually help the folks who put Netflix on their client devices. So we have an internal tool called Partner Tools, and we help these device manufacturers, mostly in Asia, some in America, get Netflix onto their device. And we certify it and test it. We figure out exactly what it is, and we put in unique identifiers and make sure that everyone who has Netflix is going to have a great experience, even though it's running embedded on a crazy variety of systems. So what we actually have is internal tools like this, for example. So our partners come to it. They can do different parts of the process to get their devices ready. We have tools for internal folks as well. We can analyze. We can say, man, this batch of Blu-ray players is having some quality issues, or this TV is not able to show Ultra HD or 4K at this time. So this is the kind of thing I'm talking about, internal site, used by some external folks, some internal folks, and backed by APIs. So really, the setup's pretty simple. We have an API server and databases. Who works on a system like this? All right, it's not actually that complicated. We have a single sign-on. We have our API server in Scala. We're actually porting stuff from kind of a more legacy service built in Grails. So we're kind of sharing a lot of the same systems, sharing the long data. But we're trying to say, look, we want to write things very clean, very well accessible, and just have everything available in Scala, which we'll be at pretty soon. So the core of this talk is, given you're going to build this, how do you build quickly and fail faster, and deploy this stuff automatically so that you can do enterprise APIs with ease? So these are the 6 areas I want to talk about today. Framework, REST, layers and tests, deployments, and docs. I didn't rhyme at the last one, but docs, no, it doesn't rhyme. All right, that's all right. So let's talk about frameworks. So when you're choosing a framework to do this kind of API development, there's a number of things you want to choose right. And there actually are. There's a good choice right now. Scala has a pretty good ecosystem in this area. So you're going to want to find something that you can download and get started out really quickly. You want something that's not going to be a big hassle when you have to do a lot of fast development. You're going to want something that's, well, I'll use the word integrated, but something that works with your setup. You need to make sure, can this work with our IDE? Can this work with our tools? Does this have to be on its own? Can we get it to work with everything we're currently using? You're going to want something that's going to make sure it fits into your deployment scheme. There are some servers which some build as WAR files, so if you already have a WAR file deployment scheme, that's great. There's some which only run command line, just another criteria for figuring out the right framework. Last one is, well, enterprise APIs usually don't need to be super fast or very scalable. I am talking about enterprise, so something that's fast enough, and fortunately, most of the Scala frameworks do meet this criteria. We happen to choose Scalatra. I think this works out really well. It's, one, we love, standards and easy listening. It's not really easy listening. This is based on Sinatra, which is a Ruby API server that has a very simple DSL. The guys called it Scalatra. They keep it pretty well up to date, and the folks that are continuing to add to this. One nice thing is that it comes pre-integrated with some of the tools we already want to use. So it has its own built-in features for ScalaTest, so you can use that to test your services. It has great oh, it doesn't actually say anything. It has great support for Swagger, which is actually developed by some of the same Scalatra folks. So this is built-in API documentation. You add a few extra things to your method, you run it, and boom, you have instant API documentation, which is huge. Having this actually built in is a great reason to choose a framework. So this is the very simplest Scalatra API call or endpoint that you can have. You extend their servlet. Here's a post. Here's the endpoint, and then we're returning created. Any questions about this? Well, again, it's very simple. Of course, you might wonder what's created. Well, this is actually, and I might test you guys on this. This is an HTTP code 201. If you have a post, you say, hey, I created it, and you return it back. Nice part is they have a wrapper for this, so you don't have to remember, is this 201 or 400 or 409 or formula 404. Any of those are taken care of. You can just say, look, hey, I've created it. I'm good. I don't have to remember the code. Another example of what you may want to look for, convenience in a framework. This is something a little bit more complicated, but really not very much. Here's an authentication endpoint. We expect to get your username and password. We want to figure out if this is if you're actually authenticated. And if you're not, we'll return you unauthorized. Otherwise, we'll say OK, which in this is their shortcut for 200. Sure, here you go. Here's your token. Do you guys see any problems with the code here? Which is a hint that, yeah, there's a problem in here. So the problem I inserted is, well, what if you have bad input? Well, you want to make sure that if you don't specify something correctly, you can handle it. So you typically should make sure that when you write, again, this is for enterprise APIs. When you write enterprise APIs, check the input, make sure that you return good error codes, make sure that you have some kind of basic handling, and that you have really an API that follows the standards. Right, what he says. Next, I want to talk about REST. Is there anyone who doesn't know what REST APIs are? Yeah, you do. Really?
I'm serious. I was thinking about it.
Oh. Well, it's HTTP codes is the big thing, and actions. So if you can think get, put, post, delete option, and you could think in terms of returning the right action, it's huge. Yeah. All right, so I'm talking about REST APIs specifically. There are newer, there's more efficient formats, but REST is pretty good enough. I clean this up a little bit here. This is really the codes that you have. If you're writing an enterprise app, though, I think you really only need these for the most part. You should have something to say, whoa, your input is bad, and you should have something to say, okay, things are fine. If you're doing redirects or stuff, and this is enterprise, there's probably some problem. And you should probably make sure that you're not returning 500. You should have a pretty good idea. So if you're getting errors, you can clean it up. I think 400 and 200 are pretty much the OK response codes for enterprise apps. So, OK, so I said HTTP put and post and delete and such. So the actions that you do should follow what you're actually, you have create and read and update and delete for database actions, and you have the similar kind of thing for APIs. So when you do get, you mean you're actually just trying to read. And when you put you're just trying to update something that's already in the system. So it's, oh, this is a challenge one. Idempotent. Did I say that right? I only say that at conferences, but OK, so this, you can call it over and over again, has the same effect. You can create new items with post, and what does this do? Yeah, OK, so that deletes stuff. OK, so if you respect the codes, if you follow the standards, things work really well, not just because it's not that hard to do this, but people have a good idea of what's actually there. Here's just a standard way, a suggested way you could lay these out. There's all kinds of ways you could lay out your endpoints to say, look, how do you get access to these? Where do I put my items there? But most of the experts agree if you put things in terms of resources, and then even if you're doing actions, put those actions in terms of resources. So you could have say, look, I want to publish these models, or I want to approve this one model by ID, for example, or I want to search. Then it's very simple. The key thing is when figuring out these enterprise APIs is you want to put very obvious endpoints because you want your users to find them. If you're writing services, it's really no good. You want to make sure that any service you write is going to get found. I mean, really, this is your audience. If they don't find your toy, what was the reason in writing it? Pretty awesome. You have a question about this slide?
Yeah.
Oh, okay. It's 80s? Oh, is that how it's pronounced? I don't. Okay, so, right, see, I'm not going to try either. But there are some folks who say, look, in your response, when you link to other things, when you give out IDs, you should include links so that other folks know where to get it. You can do it. It seems like a lot of work. We don't do it because I'll show you the docs that we have, which make it super easy to find. The biggest thing is if you don't have good docs and you don't make it easy to find your APIs, you should include links to them so people get back a response and say, hey, here's an ID. Oh, and here's a link I can now plug in to get it. So I think that is a good fallback if you don't have docs because you need some way for folks to find the loot if you made. So it's a very good point, sir. It's just that this stuff works out really well. It becomes more obvious to folks and becomes more findable. I highly recommend keeping to the REST. Not exactly, but I do recommend following the REST standards. Yes, sir?
So it seems like there's a conflict between the last slide and the two slides before. So you're talking about sticking to
It's a pup.
2 slides before.
Sorry.
It seems like the standard around HTTP is to use the method as sort of the verb, and then the resource is the noun, the object is the verb.
It's true. It's not a perfect example. It could have been more of a publishing or more of a resources. It's hard then that you only have 4 actions, though. So if you want to change something, you have to put in post.
So I guess my question is, do you find how do you see the trade-off between an API like this where
Yeah.
it doesn't really make sense to get and approve?
Right. It's not reusable. Yeah.
Right. And how would I, for example, publish model/123? Would I post to approve or would I put it like it's a little bit unclear.
That's why I think you should. Yeah. You should have docs that should make it clear exactly what's in there. Like you should have an inventory of what's available. But yeah, it should also be somewhat guessable. So if you'd have to guess approve and think, oh, okay, is it supposed to be approve or what should I look for? Yeah, that's a hard question. This does actually do the approve and this does do the publish, but you do have to look it up to figure out is this like a push or put or post, for example. So there are folks who say, look, even this isn't very good. It's kind of a hack. Make this in terms of resources. Make it a publishing and make this an approval, and then you're getting and putting, which I left as an exercise for the reader. So you win. All right, that's a good catch.
Have you tried both approaches and found one to be more? Because as you point out, it doesn't come with documentation.
Right.
You're building this for someone else to use.
This seems to be clear enough, but it is something. The nice part of enterprise APIs is you could change things as long as you work it out with the folks using it. It could make sense. Back to the puppy. So no, not the puppy. So I want to talk about layers. This part's super quick, and this is more a matter of taste. It's just about organizing the code. I think it's really useful to make sure that you have your services cleanly set up. This is how we happen to do it, how I'll often do it, where I have core service code that just deals with validation, making sure you have the right information back, that you're giving the right response code, getting the output out, and that's it. And that you have some kind of manager layer that talks to the database, takes care of the business code, and keeps it separate. Again, you don't have to, but this works out really well. So if you want to have multiple services that reuse the same manager code, it works out really well. You're keeping the service part, the endpoint, completely uncoupled from the core business logic that you have. Again, just a recommendation. If you want to go a little bit further, it's also nice to say, look, why should I mix all my business logic with persistence code? Just having this stuff kind of separated cleanly out there just means you're going to be able to iterate a lot quicker and make more reuse of the code that you have. But you know, it's your, new stuff has come to light. This is your opinion. Okay, number 4 is tests. Who likes to write tests? All right, you guys are awesome. I like to write it. I liked it because it makes it a lot easier later on. If I have tests and we mess something up or the data goes bad or whatever happens, we find out immediately. We get big emails and frowny faces from other people. We have tests that fail quickly so that we can find out rather than having to find out down the line in production. So the great thing is with tests is you can trap a lot of issues that come up before anyone else knows how little you're paying attention when you coded it in the first place. So there's a lot you can test with services. I do recommend testing the different levels out, testing their interaction. You should make sure that you're testing directly to your services, but also to your managers for reusability. You should do some kind of basic thing to say, look, when I send this to the service, is it actually passing the right thing to the manager? And when I'm calling the browser, is it actually unparsing this JSON thing out here? I'm just saying break this down into different areas, test these individually. You could have everything else working, but it actually fails when you try to parse the JSON, for example. And the opposite's actually true. Let's say I expected something to then be returned, and I'm using options to wrap my Scala code, and I didn't actually use an explicit type, and I return it, and your callers are saying, why am I getting someone's name wrapped in some? Am I the only one who's done that? OK, so when you're throwing options out into your result and you forgot that you're actually doing that, it's good to actually verify what you're actually really getting back. I think you guys are just kind of silent, but like, yeah, I've thrown options into my data too. OK, I don't want to belabor that point too much. This is just a nice example of why it's nice to have a test framework built into your API framework, because you could then make it very easy to do something like this. So here's Scalatra suite. This is ScalaTest plus Scalatra. I can simply say, look, I'm going to be testing this servlet. This is not the real path. This is just a temporary path. I want to say, look, OK, I should be able to log in here. So oh, crap, I put my password in there. So when I do a post, inside here, it's actually calling it and getting the response back. I should get a 200 from this. And the actual text that's returned should be more than a 10-character token. Again, it's very simple, but you are then proving that your whole service works. Any questions about testing, by the way? Thanks, man. And short. It's nice just to be able to look at this and figure out, one, do I have my stuff right? And two, what is it actually supposed to do, which is great for communication.
So what exactly does Scalatra suite provide on top of the regular?
So it provides that add servlet part, and it provides this post part. So I'm saying do a post to this URL. If it's JSON, I can say it's a JSON header, and here's the content. But it has a very simple like DSL function, so I can post it, and then inside I'm passing a function, of course, where I can get the status and the body returned from the invocation.
Does it do the actual HTTP post, or it emulates it?
That's a good question. I don't know. I mean, it registers it. It calls it. I don't know if it actually goes over HTTP, but I am marshalling it, so I can like marshal JSON to text and then pass it in here, and it'll unmarshal it back. All right. So again, I like to make sure that I'm also testing stuff that should fail. So make sure. So the top one is what we call the happy path. It's good to get that part done. Once you've got the happy path and you expect everything to work properly, make sure that you got the error conditions too. Again, this is just a nice way to make sure that I'm verifying, yeah, not only is it catching it, but I have the correct error code. The nice thing is if you have users who know Scala, they can almost just look at the test and say, OK, I know what to expect back from your API. All right. Second to last is deployment. I find this part really great. I get into deployment. I'm kind of a build kind of guy. It's hard. Not everyone likes to do that. Or it looks hard, but if you do the right steps, I think it's still pretty easy. First thing I have to do is lose 100 pounds, and then I should be able to do that. All right. But no, that's a lot of work. So there's a lot of different deployment systems right now. I recommend something that makes it very easy for you to deploy so you don't have to spend time doing it. You don't want to have to work a lot on deploying because then you're not going to have time to build out the awesome number of APIs and give a silly talk like this. So this is just something we're using. We already have a system which takes the DBNs at Netflix. So what we're doing from the start is we're using SBT to manage our project. We use the SBT package war. Thanks, man. We're building out a war file with James's plugin. We're taking that with Gradle and creating a DBN archive that says, look, I want you to put this on a system with Tomcat. Here's the root.war file. Here's where everything goes. We're then using AMI to then build out an Amazon machine image and have this all go out there. You know, there's a lot. Oh, yes, sir.
Sorry, I thought you used EMs.
We use both. We switched to Ubuntu Debian image so we could pick up some newer tools. But really, either one works. I was using Gradle creating RPMs, but I'm just using their Nebula plugin.
Exactly.
So you can use both. It's very easy.
It supports both now?
Yeah. As long as we have something that you can automatically build your machine out, it works great. Next step is to make sure that you have your tests actually used. A lot of folks write tests but don't actually run them. We have a nice system set up here where after we push to our dev branch in Git, we have Jenkins come in here. You folks use Jenkins, right? So Jenkins says, hey, you checked stuff into dev. I'm going to start this up. I'm going to run 100% of the tests. If even one fails, it sends it back and says, sorry, I'm not going to merge anything. You have to fix your tests. If everything passes, from Jenkins, we do a merge to master. We kickstart a new job which says, OK, I'm going to build it. It only takes a few minutes. And then actually goes out and deploys it. I recommend something like this. Force yourself to get all of the tests running, and then it's easy. So at this point, all I really have to do from IntelliJ, when I have something done, is I do a git push. I go out and get coffee and read Twitter, and 20 minutes later, it's up and running in our staging servers. I don't really, or theoretically, I could be working during that time, or sword fighting. The point is, you shouldn't have to spend a lot of time deploying. If you're manually deploying, you're kind of wasting time. You should be very productive during your work hours, not have to do any kind of manual deployment process. This is what we have at Netflix. This is a wrapper around AWS. It's open source. It's been out for a few years. It's pretty good. We have a better system coming out soon called Asgard 2, which will include things like the auto deployment feature of saying, hey, you published your artifacts out to Artifactory or wherever. I'm going to grab them and then deploy this out to a new cluster and then turn off the old cluster. We don't have that quite there, but there's scripts and other solutions to do that. But having some ways you could quickly see what's out there is great, because then you could go to your clusters in AWS and say, hey, awesome, here's my current version, here's the disabled next version, and what I want my build script to do is to say, hey, I have a new AMI that's ready to deploy, great, I'll shut down and kill the old one, I'll deploy to the new one. If everything's awesome, I'm going to automatically switch traffic to the new one and disable the previous one. So we have something, Asgard 2 will be doing this. I know that there's a lot of automated deployment systems like that, but you should have a really nice way to do this so you don't have to deal with it at all. Set it up and let it deploy for you. The other nice thing, of course, I like is when you have a system that can do a build and then build out your Debian archive and then build out the actual AMI and then use that to bake the machine, is that your deployments are now immutable, which we all like. So then you're working with servers that never change. When you need something else, do an automatic deploy and have it start up and then shut down the old servers. One of the biggest problems is a lot of people have had issues with deploying property files or other kinds of configuration files out there, and you don't get everything updated at the same time. Use something like Docker, use items which will let you build out your machine images and deploy them as the entire machine and then never touch them. And you'll save yourself a lot of hassles so you can drink coffee, read Twitter, sword fight, or build APIs. All right, last one I have here. Oh, wait. I forget if this works. Oh, yes. OK, so this is just an example of what I talked about. We have the system saying, hey, we're going to go ahead and deploy traffic out here. And then you have the nice ability that if you have a problem which your test didn't catch, you can always roll back to a previous version. It's just a single click in Asgard to say disable this and enable that. I recommend coming up with a system that makes this very easy so that you shouldn't have to spend any time, neither should anyone else. All your time can be focused on wonderful app development. Yes, sir?
How do you check that there are problems in the deployment?
Well, I set up alerts. Yeah, sometimes I set up alerts. If I ever call like a log4j error, I'm trying to set up so it'll just email us in production. I use like log4j formatting and have just an error log set up so I can just look for it. But you know, New Relic's pretty good. There's anything which will tell you that there's an error, I think, is really useful. All right, thanks. So last one, docs. Woo! We love docs, right? Who writes docs for their APIs here? Well, you're wasting your time. Oh, sorry, what's that? No. So you're wasting your time because there's actually a lot of things that'll do this for you. But I'm glad you're doing it because docs are really important. So I think I have a little bit of time here. This is kind of an important story here. Don't speak up if you heard this one. So there's this guy going around on all fours on the street corner underneath his street lamp. And a police officer is walking his beat and walks up and sees this guy and says, "Hey, buddy, get up." And the guy says, "I can't. I'm looking for my room key. I can't find it. I've been looking all over." And the officer says, "Okay, I'll help you." And the officer gets down on his hands and knees, and he's trying to help the guy find it. After 5 minutes, he says, "Look, buddy, we've looked all around this corner. I can't find it. Are you sure you left your keys here?" And the guy says, "No, I dropped them up the block." The officer says, "Well, what are you doing here?" And the guy says, "Oh, well, the light's much better here." All right, it's like 50 years old, but I like that joke. Anyways, I think that's very illustrative because when you have an API, the only APIs that your users are going to use are the ones they see. If you have APIs that are not documented, if you don't have APIs that are easy to access, people are not going to use them. So you've kind of done a lot of work and created a lot of awesome tests and really doing a lot of deployments for nothing. So if you write an API that you don't want folks to use, don't document it, but then why write it in the first place? Make sure you have really good docs and people can find it, because if they can't find and use it, they're not going to make use of it at all. All right, see, it was a necessary joke. I had to, I didn't have a choice. So yeah, the big thing is, if you show up and make it easy for people to find, much better chance that they'll actually use it. So this is an example of Swagger. This is the built-in tool I was talking about. You have built-in support with Scalatra. It's pretty easy. The nice thing is when you have this done, you have this beautiful rainbow view organized by the actions that you have. And you make it very easy to say, OK, I want to click and look into it. And it's awesome. They create HTML fields for all of your input forms. You could paste in a JSON. You have documentation about what this actually does. You can add notes. It'll take your case class. I know it's by the bottom here, which isn't a great idea. But this is a case class that it'll then automatically convert into documentation for you. It's awesome. It actually requires very little work to get this to happen. So here's our authentication item again. The only thing we have to do to get this into Swagger is we have to say, hey, by the way, this is a Swagger operation. And when people want to look at it, I'll say, oh, well, this returns a token response, so make sure to take this case class and turn it into documentation. And here's the name of it, and here's the description, and here's the 2 parameters. And Swagger will take that, and it'll build out all the documentation, it'll build out a form. And the nice part is, this then becomes kind of your dashboard. Not only is it your documentation for people to find it, and not only is it an inventory and catalog, but it's very interactive. There's buttons so you can actually try out your whole API here. It's not just Scalatra, I think, that has Swagger. You can generate the JSON yourself, but if you find a framework that does it for you, you're going to be a lot more productive. All right, I think that's 6 of 6. So let's say we take this, we say, look, here's the title of it, here's the 2 parameters. If we then Swaggerize it, this is what we get back. We actually get JSON back. This is their front end that takes the JSON that describes all these fields and turns it into an interactive form. You can do it yourself if you want, but the great part is we could try it out, put in a user and password, test it out, and actually see the response. Interactive documentation, I think it saves a lot of time. Yes, sir?
If you go back to the previous slide.
Yeah.
So your description of the implementation post-looking the Swagger, it's actually got nothing to do with the implementation itself. So there's nothing really to prevent them from getting sick.
Yeah, I mean,
so
I could change that to user 2 or something, and I wouldn't change that.
So it's not like you have to wait to test.
No, I mean, you could really screw with people. It's true. The good thing is that you can test it out here. So that I would recommend testing it. And of course, if you change it, the docs are wrong, it might be OK, but you won't be able to use it. So testing it manually is always a good idea. Good point. All right. What's that?
Testing manually is never a good idea.
That's what this gives you. You can actually see it. You can see how it works, try some things, make sure it works. It doesn't take very long. All right, so that's 6 of 6. That's the big thing. I just highly recommend if you're doing enterprise APIs or you're doing something similar, pick really great frameworks, stick to the standards, do good tests and docs, and make sure that you can spend your time, surfing Twitter or whatever it is you do, instead of having to do all the drudgery. I meant at API development. All right, that's everything. Thanks, folks. Any other questions? Yes, sir.
What's your recommendation with dealing with API changes, like versions of API? How do you, there's various ways, but what works for you?
Well, for the enterprise, we usually try to keep track of who's actually calling our API. So if no one's accessed it in a month, we usually just go ahead and change it. If they have accessed it, we talk with them to see, hey, we don't want to have 2 versions of our API. We work in the same company. Let's work together and roll out stuff out at the same time. If you do, some people use a standard like /rest/v1/v2, and that could work. But that's a pain, because then you have multiple versions. The great part about enterprise is it's used internally. You should know who's calling it. I recommend fixing it. I don't like disabled code. I delete code all the time. I don't like to disable stuff. You should keep things, I think, very well maintained. And you have Git or something similar. You can always roll it back if you need to. All right, any other questions? Yes, sir.
Yeah, so you described like the stuff like how to discuss the right way. How about psychology?
Yeah.
Like you deal with people that have different views, right? I mean like those APIs, so you have like the right view of things. That's what I think.
Oh.
But in a big company, like you promote good APIs. How?
Well, that's a good question. We have a few different users of our stuff. We have other teams. We have front-end developers. We have folks accessing it from Groovy and Java. So it's a mix of use for websites and use for other systems. I don't know. I haven't really had problems with it. The fact is they know where to find everything we have. They can interact with it. They can test it. If they need extra things, we'll add it. We usually don't remove, just to keep things compatible. But it usually does make sense to iterate pretty quickly. If we do change something that breaks something, we won't be able to even get our code in. Every test has to pass for us ever to merge to master. All right. Any other questions?
So how do you guarantee no downtime for that API?
Sorry?
How do you guarantee that there's no downtime for the API?
Oh, OK. That's a good question. Sorry if I kind of sped past that. So we're using Asgard. And we have an automatic deployment system. So what you have here this is clusters. It's kind of an idea of an auto-scaling group, but with the idea that you have a single Jenkins build here, which is numbered for each one. So the code on here is different from the code on there. We make sure that we always have at least one cluster up and running, so that if this cluster is fine, we'll shut down this cluster. But we make sure we don't have no clusters available. So if you do that, then you're automatically rolling out to a new cluster. You verify it's good. You shut down the old cluster. People are switched over, and you never actually have a downtime at all. And by using immutable deployments, where's immutable? By using immutable deployments, you're making sure that you don't need to shut things down, that you don't have to copy things over. You have everything ready on a new image that you need. You can deploy that out to pools, and when it's all ready, you make sure it's good, and you shut down the old one, and you're all set. So your deployment system can help make sure that it'll maintain and move stuff out for you, so you never actually have 0 things running at a time. Does that make sense? All right, great. Well, this has been fun. Thanks everyone for coming. Thanks for Stride Health for hosting this place. Appreciate it, Matt.